Okay, we're on page 85 of the note spiral, and this is on geometric distributions. And so this will be the introduction video. We are going to start off by saying that we're going to talk about Bernoulli trials first. And a geometric distribution is a type of Bernoulli trial. A Bernoulli trial is an experiment that has a success-failure component, or basically it can be defined as success-failure, or true-false, or yes-no, or win-loss. So basically it has two possible outcomes. So also the probability of success is constant and the trials are independent. I do want to talk to you real briefly about the success-failure component because this can be a little bit confusing. Because it says that there's two possible outcomes, but when you roll a dice, you can either get a 1, 2, 3, 4, 5, or 6. So it has 6 possible outcomes. However, if we say you have to roll a 6 to win, then the rest of these are losers. So even something that has multiple outcomes might be defined as having two possible outcomes, as in failure and success, or win-loss, etc. So you need to look to see how they've broken it up. They could have just also said that if you rolled odd numbers, you win, in which case a 1, 3, and 5 are winners, 2, 4, and 6 are losers. And once again, you're still working with a win-loss situation, or yes-no. Now, please remember, probability of success has to be constant. It can't change, and the trials need to be independent. Well, a geometric distribution satisfies this because a geometric distribution only has two possible outcomes, and we use P to represent success, and I use Q to represent a failure, and Q is just simply 1 minus the probability of success. The trials are independent, and the probabilities don't change. Now, we have this formula, which is the probability of failure. K is the number of trials. So probability of failure raised to the number of trials minus 1 times the probability of success. And we've already been doing this in this class. And if we go back to rolling a 6 is a winner, well, what's the probability the first success is on the 5th roll? In which case you'd go 1, 2, 3, 4, 5. This was a success because you rolled a 6. And these were all failures, and there are 5, 6, 5, 6, 5, 6, 5, 6. And that's work shown, and that's what we did previously. And you already know how to do that. And of course, we can abbreviate that as 5, 6 to the 4th power at 1, 6. Well, 1, 2, 3, 4, that's where the 4 comes from. But remember, we did 5 things. Well, that's 5 minus 1, giving me that 4. And so we already know how to do this. But the calculator is going to make this very, very nice. Okay, so the mean, or the expected value for geometric, is 1 over P, or 1 over the probability of success. And once again, this is something you already intuitively have been doing. Because most of you will tell me if I flip a coin, if I flip it twice, I expect to get at least 1 heads. So flipping a coin, I flip it twice in order to get a head. Well, why is that? The probability of a heads is 1 over 0.5. So 1 over 0.5, because 0.5 is the probability of getting the heads. And so 1 over 0.5 is 2. And it's like, oh, yeah, we flip it twice in order to get a heads. Why? Because the probability is 0.5. So we've already been doing that. Now, one thing that, and then we have these formulas here. I'm not too worried about them. You're just going to plug in. But here we just real quickly, failure over probability squared is the variance. And the square root of the probability of failure over the probability of success represents standard deviations. Geometric distributions are generally phrased as the first. So we're always looking for the first success. And either they're going to use the word first or they're going to imply that the first is coming. If it happens on a specific trial, like the first success is on the 5th trial, which we have up here, then this will be a PDF. If it's a specific specific trial that we have a success. So geometric PDF is on a specific trial. If it could occur on one of several different trials, then it'll say what's the probability the first success will occur no later, or by, or within, or during, in which case by the fifth trial. Well, that means it could have been the first, second, third, fourth, or fifth, in which case we have a CDF, a geometric CDF. All right. One thing about the geometric distribution is it's possible, maybe not realistic, that we never have the first one occur. So when I flip a coin, it's like, well, what's the probability the first heads will occur on the fourth one, or the fifth one, or the sixth one? It might never occur. The first one might never occur, and that's one thing that kind of makes the geometric a little bit interesting, is there's always a chance that it won't occur. So we're always looking for the first. So suppose only 17% of guys at some high school, Reagan, are honest. What is the probability that the first honest guy that a new girl at school meets will be the fifth guy to whom she is introduced? All right, so real quickly, we have a probability, well, the first, this right there tells me it's a geometric. This right here is my probability of success. So my probability of success, and you always need to make sure you show it somewhere, probability of success is 0.17, or the probability of her success, and the probability of failure, Q, is 1 minus that, or 0.83. This tells me a geometric, but it wants to happen specifically on the fifth guy. So specifically on the fifth guy makes this the PDF. And some of you are rushing ahead, and I don't blame you, and you're going 1, 2, 3, 4, 5. This guy's honest, so 0.17. Liar, 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 so this is 0.83. And I'm just going to shorten it up. So my work is 0.83 to the fourth power times 0.17. Now, real quickly, we can sit there and say, you know what? There's my formula. 5 minus 1 is 4. And technically, this 17 has a little 1 on it. So the 4 plus 1 gives me my 5. And by the way, I don't mind you leaving that exponent. I know in math class it kind of complain. I'm going to rewrite this so it shows up a little bit better. So 0.83 to the fourth, 0.17 to the first. In math class, I don't like having that exponent, but if that helps you here, 4 plus 1 being 5, there's nothing wrong with it. We do not deduct points for that. AP won't care, and I won't care. I just mainly want to see that you get the right answer. I'm going to see if I can help my lighting just a moment. Just a little bit. There we go. That's a little bit better, not much. Is there anything I can do to help that out? I don't know. All right. So hopefully you can see the screen a little bit better, but it's not great. So we're going to do on a calculator. Well, first off, we're looking for the second button, then the vars button. So second vars. In this case, we're going to scroll way down to geometric PDF. All right. And press enter. And by the way, I'm going to go ahead and write this out in calculator speak. So this is going to be a geo PDF. My number of trials, we're going to try it 5 times. Oh, excuse me, I'm starting off in the wrong spot. So we're starting off with P, my probability of success, which is 0.17. And we want to know if it's, and so this is going to just type 0.17 right there. And our X value is the number of times we are trying this, and this is going to be on the 5th. We want to have it on the trial on the 5th success. So we found the honest guy as the 5th person she met, and there's about an 8% chance of that happening. Now, this right here would be your work shown, and if you had all of that, that's great. If you wanted to use the blanks and just put it to the answer, that's fine. But if you do use the blanks, make sure that you fill them all in. All right, very important to fill them all in. But either this or this with the answer will get you full credit. Now that's a geometric PDF. But here we have a slightly different question. What's the probability that the first honest guy she encounters will be no later than the 4th guy she meets? All right, this is interesting because we see first, and so that lets me know we're working with a geometric, but no later than the 4th. That means it could be the first guy, the second guy, the third guy, and the 4th guy. So it could be any one of those multiple values. And because I have multiple values, this is going to make this a CDF. Now, for the time being, we're going to do this slightly differently. We're going to do it the long way, and we're only going to do it this long way once because I want you to understand what's going on. Because a geometric CDF is essentially the combination of the PDFs. It's a combining of them. So in this case, and really this means cumulative. PDF is probability density function or probability distribution, and this is cumulative density function. So this one is the sum of all the PDFs. So basically, I need to do a PDF of 1 plus a PDF of 2 plus a PDF of 3 plus a PDF of 4. And we're going to go ahead and do that on this particular one, just because I think it'll help out with the general understanding. All right. After that, we're going to change this up a bit, and we won't do that again, but I feel like it's pretty important for this one. So here we go. So we want to know the first one. Well, the first one is just going to be, is very, very easy. We just have one blank. It's honest, and the probability that it's honest is 0.17. And also we're going to do this on a calculator too. All right. The second one, well, we have to have two blanks. Well, the first one is a liar, the first guy, but the second one was honest. So we have 0.17, and this is 0.83. The third one, liar, liar, honest. And sometimes it helps to put all the labels in. I'm certainly going to do that when my notes. And sometimes I do that when I'm actually doing the work to make sure that I actually am thinking about things right. And the fourth one is liar, 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 and then honest. 0.17, 0.83, 0.83, and 0.83. And yes, I know this is taking a little bit of time, but it's worth it, I think. So essentially, this is going to be 0.83 to the 0 power, 0.17 to the first. This is 0.83 to the first power, 0.17 to the first. 0.83 squared times 0.17 to the first. And then 0.83 cubed and 0.17 to the first. Now, real quickly, 0 plus 1, that's my first time. It's 1. 1 plus 1, that's on the second trial. 2 plus 1, that's the third trial. 3 plus 1, that's the fourth trial. Okay, so we're going to go ahead and run these on the calculator. I should scoot that up so you can see it, even though the writing's a little bit poor. So second vars, geometric, PDF. Probability of success is 0.7. And we want this to occur on the first trial. And we go, oh, we get to 0.17, but we already knew that that was going to happen, but we have 0.17. On the second trial, so second vars, and I'm going to speed through this pretty quickly. So geometric, PDF, set 0.17 and the 2, and we get 0.1411. This is for the second one. Then we get to the third one, second vars, geometric, PDF, and oops, I hit the wrong button. Second vars, geometric, PDF, 0.17, X value is 3 for the third one. So the chances it's on the third guy is honest and not the first two is 0.117, 113. I'm having trouble writing. 117, 113. And the chance that the fourth guy is second vars, geometric, PDF, and I need to change my X value to a 4 because it's the fourth guy. And I get 0.0972039. 0.09720379. If I add all of those up, I end up getting 0.525411679. And that took a fair amount of work. I had to show a fair amount of work, and it took a fair amount of work to actually get there. The nice thing is the calculator will speed this up a whole lot. So technically, because we had to add all these PDFs up, we have a CDF. So we have a geometric CDF. This is the calculator for work. Geometric CDF 0.17 is my probability, and I want to know the probability that it happens on the fourth try. So here we go. Try it on the calculator. So second vars, geometric CDF, probability of success is 0.17. The X value is 4. And there we get 0.52541,679. And we're excited because all of a sudden we're like, gosh, that saved a whole lot of time. And I don't know about you, doing it 4 times took a lot of time and I wouldn't like it. What if I'd had to do this 20 times? Chances are I'm going to make an error. So the CDF button will save you a lot. But now you should be asking yourself, hey, but Mr. Spencer, I know I'm going to have to show work for this. How much work do I have to show? And the answer is, well, this is where we can shortcut it a bit. We can do the first one and the last one. Well, the probability that it happens on the first one is 0.17. And this will always be the single number, and it'll always just be the probability. Plus dot, 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 the probability that it happened on the last one. Well, what's the probability it happened on the last one? Well, first off, I'm going to need 2 blanks. Well, the probability of the last guy is honest, is 0.17. And we had to have 3 dishonest guys, and I should have written that up here. This is honest. These are liars. 0.83 to the fourth, 0.17 to the first. So if I have that, and then equal to 0.52541,679, this right here was what I would need to show work in order to get full credit. So 0.17, because that's the first one, 0.83 to the fourth, 0.17 to the first, plus dot, dot, dot in the middle. So how many guys does she expect to have to meet to find the first honest guy? Well, a couple things. First off, I see the word first. So this lets me know that I'm working with a geometric. But they didn't ask me for, they didn't say that you find the first guy. They expect to find it. So on average, it was like, oh, they say the word expect, so they must be looking for the expected value. And we know that the expected value for a geometric is 1 over p. So in this case, it's 1 over 0.17. And when we do that on the calculator, we end up getting 5.88. Now, real quickly, this is something that people are struggling with on tests. So I'm going to do it here, although I probably won't do it again in the notes, even though maybe I should. It should say, on average, or in the long run, we would expect her to have to meet 5 guys, well, that's a restaurant, to meet the first honest guy, to meet 5.88 guys. Should have said 5.88 guys. So on average, or in the long run, we expect to have to meet 5.88 guys, and I should say 5.88 to meet the first honest guy. Now, this is really important. We don't round on this because unexpected values, matter of fact, never round on unexpected values. And they're like, well, I'm hoping there's not a 0.88 guy out there. And yeah, that would be kind of sad if there was. But what they're saying, if we did this over and over again, she might, the first one, she might meet the first honest guy on the first one, or the second, or the third, or the 6th, or the 10th, or the 100th. But on average, If we did this over and over again, she's likely to meet the first honest guy on 5.88 on average. That's what we would expect. And that's assuming that the probability is 0.17. All right, assuming that that probability is 0.17. Okay, so that will conclude the introduction to geometric, and we're going to do some practice problems in just a moment.